So what you're seeing on the board is basically we're talking about meiosis produces gametes, haploid cells, and haploid cells are n the number. N the number is 23 chromosomes from mom, 23 chromosomes from dad, produce a diploid. That's the nasty, right? Down dirty. All right? It produces offsprings in the pedigree. Okay? Everybody follow? And we have Mendel to thank for some of what we understand about genetics. This is why we call classical genetics Mendelian genetics. Of course, there are other forms of diseases that occur in humans that Mendelian genetics cannot account for. Okay, for example, polygenic inheritance. Okay, what does polygenic inheritance mean? Anybody? I'll write it on the board. Polygenic inheritance. What does that mean? Polygenic means what? Many genes. Yeah? And don't we inherit a lot of genes? Inheritance. So polygenic inheritance, guys, means the many genes that we inherit. Well, because we inherit so many genes, and because those genes have variation in them, not only that, genes can jump. So we have jumping genes. We have genes that are repetitive. So we have genes that are junk, purely junk. What do I mean by junk? Anybody know? When I say we have junk genes, what do I mean by that? We have genes that we inherit that encode for absolutely nothing. Do you understand me? They're there to help stabilize the DNA structure. And the majority of those, again, this is something that you would know if you had taken me for 2085. If you remember, AT produces 2 hydrogen bonds between them. But GCs produce 3 hydrogen bonds between them. So we have large numbers of GC repeats within the DNA to help stabilize our chromosomal material. How do you like that? Make sense? Sure enough, these CGG repeats or GCC repeats or whatever it is, you look it up. Huntington's disease. Huntington's chorea. A disabling disease where you get a tremor at rest, but when they go intend to do something, they can do stuff. But at rest, they're tremoring. And sometimes it's reversed, but as the disease progresses, it gets really bad, where they're tremoring all the time, even when they're at rest or even when they're moving. When they're moving, their movements are erratic. Because this disease called Huntington's disease, Huntington's disease. I'm sure I spelled it wrong. Huntington's, T-O-N, I think it is. Huntington's disease is because of these repeats, these DNA repeats, these increase in DNA repeats of junk DNA, guys. But sure enough, because it's repeats of junk DNA, it can encroach on good DNA. Did everybody hear me? And if it encroaches on good DNA, then you got a problem. Yeah? Sure enough, that's not the problem. The problem is you got too many repeats. Somehow the repeats expanded. So they call them triplet repeats, or triplet repeat expansion is what they call them. And they don't know why. Just out of nowhere, like a section that's junk that should have like maybe 23 repeats, like anybody else, right? Starts going from 20 to 30, 30 to 40, 40 to 60, 60 to 70, 80, 90, and all of a sudden, once it gets past a certain number, now you got problems. And the more severe, the larger the number of repeats, the more severe the disease at the younger age. Isn't that interesting? So the larger the repeats, the larger the increase in repeats, guys. The larger the increase in these DNA repeats, what do they call it? They call it there's a word. increased penetrance. Look it up. Penetrance. Look it up. Penetrance. Look at the word penetrance. The word penetrance has to do with how insidious the disease develops, I believe. So if you look up the word, let's see if I'm right or wrong.
An extent to which a particular gene or set of genes is expressed in the phenotypes of individuals carrying it, measured by the portion of carriers showing the characteristic phenotype.
See that? So again, they keep talking about genotype, phenotype. So what you inherit genetically manifesting itself in something physically. Yeah? You see? And so once I have these increase in DNA repeats, I get this thing called increased penetrance, which means I get this increase in the effect of the physical trait that the gene encodes or doesn't encode for. Sure enough, the only thing that happens when these triplet repeats expand is motor I'm just spelling shit all kinds of wrong. Motor dyskinesia. Coriform-like dance movement. So when they go to walk, the arms will start flailing. And when they're walking, their arms are flailing involuntarily. They have no control whatsoever of their limbs. They lose control of their limb musculature. That's how severe the disease can get. And it can show up at the age of 20, 25. Depending on the penetrance versus the expressivity. So you have expressivity versus penetrance. Okay? The less it repeats, the less penetrant. It means I won't develop disease till later in life. You see? See? The sooner, the increased penetrance, the increased risk for early onset of disease trait. For early onset motor dyskinesia. So if I increase my DNA repeats, I increase the penetrance, and I'll increase the risk for early onset of motor dyskinesias. You see that? So if my repeats are not, they're larger than normal, larger than 23, but they're not like at the 70 range, then I may not get the disease till like I'm maybe 60. Right? It gives a shit, right? Or 60 or 70, right? Because by then I'm probably dying anyway. Right? Who cares if I get a dyskinesia? Put a bullet in my head, right?
60 is the new 40.
60 is the new 40, yeah, right? You see all the cougars running around, right? in the tight jeans and the high heels, man. Cougar season. Well, I gotta be careful. become somebody's kitty food, boy. But then, it's interesting because I had a student who I'm tutoring. But